involves three outcomes or three models that we will come up with. So far we have come up with the conceptual model. So what we did in the conceptual model, we identified the data elements that are needed for our project, for our databases. How did we come up with those data elements? We used several techniques. We used observations, we read business documents, we interviewed end users as well as managers, and we also surveyed. Although we might not have surveyed here, but those are the techniques how we extract those data elements. And within the interview, we looked at two specific techniques that can allow us or help us identify the entities. And those are entity identification technique as well as characteristics identification technique. So what did we do? In the entity identification technique, we asked a broad question, open-ended question, to the end user or to the manager, and we asked them how do you perform your work on a daily basis? And you ask me that question. And the end user will answer that question broadly. They will keep talking and talking, but for me at least, I use maybe one or two sentences to answer that. And from there, and this is what we did. So I summarized it here. So that was the question that we used to identify the subjects or the entities. And we say that entities and subjects and tables, they have all similar names, and those similar names can include objects. So an object is a table or an entity. Also, we have subjects here that helps us also identify those entities. So how did we identify those entities? We say any subject in those sentences that the end user or the interviewer would answer and mention, we will underline them as possible entities. And that's exactly what we did. We highlighted it, and we looked at each one of those subjects. So we discovered those entities. And then when we looked at those several entities, we decided that we need to know more about each entity. We needed to understand the characteristics, the attributes of each, or which will become our fields for each of those entities or tables. And this is what we did. We asked another question, and this question is, you can ask it in any way you want, but for me, I prefer asking this question in this way. Talking about professor, what data is, or what data are needed? Data is a plural. So talking about professor, what data are needed for the professor? So what data are needed when we discuss the professor entity? Just throw some. So the class they teach. What else about themselves? Their name, first name, last name, middle initial. Maybe they have an ID, and that ID can be a potential primary key, isn't it? So those are some of we need to know their specialty. We need to know their email. At least for this specific part, we are kind of assuming that we are building this database for the university, let's say. But it is very simple. So there are so many entities that I haven't mentioned, but I'm just mentioning those simple ones. So we need to know the rank of the professor. We need to know their specialty and email. So let's say those will be enough for us. And then we have other entities that we have kind of identified earlier. We have classes, we have courses, we have departments, and we also identify rooms, which means classrooms, and so on. So after we answer all those questions, identifying and extracting the characteristics or the attributes for each entity, we try to group them into a group that we can call it an entity. So after we we discovered, or we tried to discover all those data elements, we just stitched them in a mind map. And this is what we did. We created a simple mind map that tells us some of the data elements that are needed for our database. Just throw it out there. From its name, just helps us think better. Now, when we are done with the mind map, we need to put it in a class diagram. So that means we need to group those, each entity with its own characteristics or attributes together. So you can put it in this format, in similar format like this. This is kind of an initial way of creating a class diagram. First, you group those entities with their attributes, or those entities with their fields that we are going to use them later on in a table. So we need to collect some information about the student. So what is important we need to collect about the student? You can see here that are the relevant information about the student. What if in the interview, when you ask me that question, I said I like to eat, let's say, fish? Would that be also included in one of the entities? In fish would be an entity? Yes, it is an entity, but is it relevant in this database? It is not. So that's why we select only those relevant entities. And if something that is not relevant, that is not needed for us to do our job, then we ignore that entity. So that's the first step. Now we put it in a class diagram. So all of you so far have access to Visio. So this is what you will need to create every entity with its attributes into a class diagram in this format. And then you will connect it. So when we look at those entities, then we need to think about the relationships between them. Just by looking at them, what is the relationship between, let's say, a professor and class? Who can tell me, like, what is the relationship between professor and a course or a class? That's correct. So the name of that relationship is teaching. So a professor teaches the class. And then, so this is kind of the initial term that we will need for the exact relationship. And then we need to use cardinalities and modalities. Remember when we talked about cardinalities and modalities? So we will come to that. But let's now think about the relationships between those entities. So what is the relationship between, let's say, room and building? Classroom and building. Perfect. So a room is contained in a building. And a building contains a room or rooms. So that's correct. So that's the exact term that we use for this relationship. So now we got the idea what we mean by the terms for relationships. Just to add to the names of tables, entities, objects, also relations. Relations also refers to a table or an entity, just to add that. But now we are talking about the relation terms. So the relationship between those two things. How about a professor and a department? What would be the relationship between professor and a department, in your opinion? There might be several, but let's think about one that is very common, that comes to your mind. Okay, so all works enough. So a professor belongs or works in a department, and every department employs professors. So now we got the idea that we have terms that you can create them yourself. And those terms also come through the business rules, through the interviews, through the data collection that you have collected. That would help you kind of come up with those relationship terms or terminologies. What about the relationship between class and course? So there is a course and there are different classes. So let's say that I'm teaching a database course, but I have different classes. I have face-to-face class, and I have hybrid class, and I have an online class. So now every course has 3 classes, and every class belongs to only one course. So, so we came up, so we already discussed those relationships, and this is kind of the overall diagram that we can look at. I hope that you can see it. If not, it is available. Those slides are available in Blackboard, so you can see them better. With this one, just moving, sometimes it works, sometimes it doesn't. So now we can see here, we have connected those entities with each other, and we also included the terminologies between those. So you can see that professor or the department employees professor. So I didn't mention the cardinalities yet or the modalities yet, but so far you are all familiar with it because we have covered it. So let me do one cardinality for you, and then I will ask every two of you to work on the cardinalities and modalities between two entities. So let me start with an example. So what I'm going to do is the relationship between professor and department. So this is the relationship between those two entities. I'm going to create the modalities and the cardinalities using the class diagram. So what I will do, I will just use text here, and I'll put it here next to the professor. So, and I want to know so the way we read those relationships in terms of cardinalities and modalities is we say every department, because employees here next to the department, so that's how I would read it. Every department employees, is it how many? Is it 0, 1, or many professors? So every department employs at least one or many professors. Is that right? So every department employs one or many professors. So let's say that's or is it one? Do you think every department in the university employs professors or not? Not all of them, is that right? In the physical plant, maybe they don't need employee professor. So what would be the relationship there? 0. So every department employs 0 or many professors. Can we say that? Is that kind of fair to say? So let's put that in we will put it in here. So we will say 0 and then 3 dots between them. And then I will say star. So the star sign refers to the name. Other people use the M or N, but let's use this one for the class diagram. So that's how when we read it one way. How about reading it in the other direction? So we say now every professor is employed by one department, or 0 department, or B. Which one would you think is scale? One and only one. So that makes sense. Every professor is employed by one and only one department. So this is how we will illustrate it or depict it. So we'll say 1, 3 dots, and then 1. So this is done for us. So now I will ask every two of you to work on only one relationship between two entities, and then report it to the class. So you two, you will be working with the professor and student relationship. You will be working with the student and department. And you will be working with the student and class. And two of you, well, two of you and then two of you. So two of you will be working with the class and room, and then two of you class and course, and then two of you will be the building and room, and then three of you, I would say, department and course. Okay, so let's do that. So I'll give you 2 minutes, and then we will see the report from each one of you.
Well, I guess it could be one. No, that. What they have to do. Like an house.
Oh, yeah. So it seems to be everyone is done? Okay, great. So now let's see every team, what they can tell us which entities they were assigned and what they got. So let's start with the first team.
We put every professor advises one or many students.
Okay.
And every student is advised by one or more professors.
Okay. So when you did that, that's based on your assumptions, which can be correct, which might not be correct. So what you did is fine, but we need to understand the assumptions. And to do that, that's what we also learned from the business school. So when you interview the professors and so on, you will understand it better. So in that case, you will have to interview more, or you will interview the professor or the department chair to understand more about it, to decide what it is. So what I would say is, from my opinion, because I'm working there, so I would say every professor advises zero or many, because they might be new and they are not assigned a particular student to advise. So I would say zero or many. And then the student to professor, so we would say every student is advised by one and only one professor, because if they have too many professors advising them, then they might graduate after 7 years. Is that right? Because everyone will give them ideas about which courses to take, but at least in our department here, we are very small and we know exactly what courses to take. But if you are in a big university, then everyone will ask you to do something. So that was great. So at least you did it that attempt, and you were close. So that was your assumption. So let's look at the second.
We have every student majors in one or more departments. And then every department has 0 amendments.
So that's also based on the assumption. It is correct. So your assumption that double measuring is allowed, and I doubt that in our HIM department. I don't think, or in the PNC, I don't know if that's allowed. But for me, I double measured, so I was able to get 2 measures from 2 different departments. But here, I don't think it's allowed. So in this case, we will say every student measures in one and only one department because it's not allowed. So remember now? So now it didn't make sense what we mean by business rule. It comes in this case when we decide the relationships or the cardinalities. So every department has, you said 0 or many students based on our assumption. That's when we talked about earlier. That might be correct. And we might, based on other assumptions, it might be 1 or many. So, but that's correct. So one thing that I want you to understand is there is no one absolute truth and one absolute wrong. It's either right or wrong. It can be gray, as long as you have to explain your assumptions. So in this level of education now, when we were in elementary school, we need to know whether this is an apple or whether this is an orange. They cannot be something different. But at this point here now, you can say this is not an apple, and you prove that it is not an apple by evidence, and people will agree with you. So you have to have that evidence or assumptions and explanation why you think that's so. So let's look at the third theme.
You said every class enrolls 1 or many students. Every student enrolls in 1 or many classes.
So let's say that again. So you look at those two. The right class and course.
We had student class.
Student class, okay. So what did you say?
Every class enrolls 1 or many students.
How is this? Okay.
And then every student enrolls in 1 or many classes. Wouldn't our assumption then be that, like, if you're not enrolled in a class, then you're not a student here? And if the class doesn't have anyone enrolled in it, the class is therefore canceled and not a class anymore?
So we keep that in mind, and then we will see like what we have. But that's based on your assumptions that legitimate. So let's look at that second, the fourth.
So you have each class has 0 to 1 room, and every room can have 1 to many classes.
So every class can have 0 or many. So assuming that you have online courses,
Yeah.
so that makes sense. So that's your assumption. All right, and then every room
1 to many classes.
is assigned to. Every room should be assigned to only 1 class. Is that right? Or many? That's true because it might be in different times. In different times. Is that what you assume? So that's
This room
also.
will be utilized just for 1 class.
So perfect. That will work as well. So we will see what the solution looks like. So now let's look at Derek and Diana. Okay. So we will move on. So we will see. Let's see Naomi.
Every room is located in one building. Every building is located in one building.
That okay. So let's look at that. Third.
So we have every department offers 0 or many courses. Every course is offered by 1 or only 1.
So let's look at what the solution here might be might differ a little bit from what you have, but those with the assumptions. So let's look at this one. And then you can fix what you have based on this. So which ones were different? Theirs were different from what we have here. So yours was different. So yours was between,
If we had like, we did one of many departments, that percent.
okay, the student and department, okay. So here it says that every student majors in one and only one department, because the assumption. So we choose that. And then every department that have a 0 or any students. So Derek, so was yours correct? Diana? It was? So which one was yours?
Course class. So
Person class?
it's every course has 0 classes. Like,
So yeah, so that every course has to have class. So that's kind of, logically, it makes sense. And then every class should belong to one and only one course. So which you got it right, that. So great. So what was yours? You already talked about it.
Yep, we did this.
Kelly?
Ours is different. Because we said there has to be one. We said one to many, not 0. But I don't understand how you can say that.
So which one was yours?
Student in class.
So, okay. So here it says student enrolls in 0 or new classes. That student may be in origin, so that's the assumption. The student is just maybe, let's say they got pregnant and they decided that semester not to take class. So they are still students, but they are not taking class. So that would be our assumption. Does it make sense? Maybe they are injured, or so. I don't like to say negative, but let's say those are kind of the reasons why we might have that issue. And then every class is enrolled by 0 or many students. So there are some classes, maybe they are not offered in that semester. For example, a database is not offered in the fall semester. So that's why we have 0 or So your team? So what was different in your?
the only difference we have is that the classes that we do one and only one person, but it's an online course, it's an assumption, it would be different.
Can you say that again?
Like on there it says like each class is scheduled in one and only one room.
Okay.
But if you're in an online course, half of them.
So that's, yeah.
Zero
That's,
to one outline.
so yeah, depending on the assumption, can be either way. So let's see the next team. Natalie.
The only one who has located one
Because there are some buildings, maybe for me, I worked in the maintenance when I was a student in the summer, and then we had a building that was a hangar. It doesn't have rooms. It's just all kind of only one space. So maybe that's the assumption, which might be logical. So every building might have 0 rooms or many. So we'll assume that. That's what they.
What would it be? The building is 0 rooms, so it would be the, it would have to be, if I would have just one big room, still one.
So that's a good suggestion. But let's say that here, what they meant by room meant classroom. Would it make better sense now? If it's a classroom, yeah, maybe some buildings they have research labs, like Hemingway. I don't think they have any classrooms, but they have just conference rooms. They have research labs and so on. But so that would be maybe the assumption. So the last team, yours was correct? Okay. So now this is what we have. So now we are done with the cardinalities and modalities. But now we will move to the second phase or model that we are gonna be. So this will be kind of our logical model where we decide the modalities and the cardinalities. Now we will need to decide how we are connecting those entities. So remember when we say that we are going to connect those entities, how are they going to be connected by? So how are they going to be connected? How are you going to link those entities or tables? Primary keys and foreign keys. Perfect. So now, in this case here, I don't see any connection between those two guys. Do you see? Are they connected? Is there a foreign key in one of them? You see this in terms of this relationship? So that means they are not connected yet. But clinically or conceptually, we connected them. But are they ready to be tables yet? So in that's a process that we are going to discuss today. How to decide where the foreign key will be located. So that's our main purpose of today's lecture is to decide where would be the foreign key located. Is it in this table or we will put it in this table? So to do that, we have rules of thumb and we will go over those to decide where we are going to put the foreign key. So let's look at this. So now we are in the process of converting entity relationships. So that's what we had, entity relationships so far. We are going to convert them into tables. And to convert them into tables, we will need to first distinguish between the cardinalities between them. Are they many to many, one to many, and so on. And we want to connect them through a foreign key. So now this is the table that we have, or this is an entity that has several attributes, and by default you can say that the best primary key for this table is the salesperson number. So anything that has number code or ID can be a good candidate for a primary key. And we need to convert this into a table. This is how it would look like when we convert it into a table. But in order to convert them or to decide where the location of the foreign key will be, we need to look at the different types of relationships. So we have binary relationships, we have unary relationships, and we have ternary relationships. You remember those? So we will go over them today. So this is an example of converting one-to-one binary relationship. So when looking at these two entities, what is the relationship here? Can we say it is one to many, zero to many, one to one, or what? How can we decide? What is the relationship between those? So the line is circle, so we look at the cardinalities, means the part. So what is the relationship between those two? So 1 to 1. So we can say this is a one-to-one relationship. Okay. And the 0 and 1 here, those are the modalities. So now can we decide where we are going to put the foreign key? Can you see now a foreign key? Are they linked yet or not? They are not linked yet because we don't see a foreign key in either one of those. So every entity here has its own attributes, and the same thing goes here. But they don't have the attributes from the other table. You remember when you did your assignment, when you connected those relationships, You connected one attribute from one table that exists in another table, which is the foreign key, in order to link them. But here they are not yet. So we need to decide which foreign key to put where. So what do you think? Just throw in an idea. So office number in the salesperson, you want to put it here. So do you have kind of a rationale for it? Or just an opinion? Just an opinion. So that's a possibility. So the other opinion will be to put the salesperson number in the office table or office table, let's say. Is that right? That's another way. A third way is to combine both of them together into one table, which is not a good idea. Because by understanding from our understanding that a salesperson is an entity by itself, and everybody knows that. It's not only that, but also salesperson is connected to other entities and to other tables. So we don't want to mix them up with office, and then we will have redundancies. And we say the main purpose of creating a database is to reduce redundancies. We don't want redundancies. We don't want less efficiency. So we want them to be, every single cell value has to be used and used efficiently. So we don't want to waste size, capacity, and so on. So now, as we mentioned, we have three options. One option is to combine both of them, which is not a good idea. And the other option is to convert those two entities into two tables. So this is how it will look like if we combine them. So remember when we say that every office belongs or contains 0 or many salespersons? Was that one way to read it? And every salesperson has one and only one office. So that's how it was. So when we read from office to salesperson, we read it that every office belongs to 0 means some offices are empty. So belongs to 0 salesperson. That means there are some offices that are not occupied. So in this case, if we combine the two tables, we will have office number 1 that is not linked to any of the salesperson, and then we will have no value for the salesperson number, no value for this name, and so on. And we will have only data only or field values for only office number, telephone, and size. Would that be waste to have empty cells or null values? Yeah, that's a waste. We don't want that. Another thing is a salesperson here is telling me it's underlined, which indicates to me that it is a primary key. So what did we say about a primary key? Primary key can never be null. So every primary key can never be a null value. So that means if I have office number 1 that is not occupied by any salesperson, then I will not have anything to do, which not allowed. So that's the problem, why we can't combine those two tables together. So the other solution is to create two separate tables and include the office number as a foreign key in the salesperson. So this is the third option, which Mario said, and it is a perfect answer. It's actually the perfect answer for this. And the third option is, which is the opposite of what you say. Which we say it is possible. Why it is possible, but it is still a waste. But it's not as bad as combining all of the two tables together. This option here, if we say every office is assigned to 0 or many salespersons, so in this case here, if we have in the office table, we will have office number 1, telephone number, whatever that number is, and then salesperson will be null. Since it is a foreign key, it should not be big deal, at least it will be null. And then the size will be a value. So that means in this case we will have one cell value that is not used, that is null. That will be also, we already assigned it a size, that means we are still wasting. So we assigned it some values or some space, but we are not using that space. So that's waste, isn't it? It is. So that's why we don't want to go or to put the foreign key in the office table. I'll give you a simple way to recognize where to put the foreign key. Just a rule of thumb. So if we have a binary relationship, that means a one-to-one relationship, you want to put the foreign key in the 0 side. Okay? So if we have a one-to-one, we want to put the foreign key in the 0 side table. So in this case, which one is going to be? So the foreign key, where are we going to put it? In the salesperson, because it is in the 0 side. So is that simple? Makes it much better? So now, having understanding, or having that we understood all the reasons why we should not put it here or combine both of them, and why we put it here, then this makes it very simple for us to remember. Now looking at another relationship here. We have one-to-many. So we have one-to-many relationship. Is that right? Or I'm reading it wrong? Everyone is sure? So one-to-many relationship. Now, who can tell me their opinion? Where should we put the foreign key? So far they don't have a foreign key, either one of them. So where should we put the foreign key? So I'll let you discuss among yourselves and see what's your opinion. What's your opinion? So the customer? Okay. So do you have Rashida? No? So, but she got it right. Like Mario, you got it right. This is perfect. And I will give you the rule of thumb for this one as well. So if we have one-to-many relationship, we put the foreign key in the many side. Is that very simple? So if we have one-to-many, you put it in the many side.
On the what side?
Huh?
On the what side?
In the mini. So this is the mini, the car's leg. Is that what we call it? So we will put the foreign key in the car, in the mini side. So what do you think will be the foreign key here? Who can tell me what the foreign key we will put here? Perfect. So when we take the primary key of one table, we put it in a different table, that's what we call it foreign key. Perfect. So that's exactly correct. So now we understand where to put the foreign key, because this is a major decision to make. And why do we care about this, where to put the foreign key? To reduce that waste, make it more efficient, and to also be more efficient when we are concerned about the data integrity. What do we mean by data integrity? Means if we are going to update anything in the salesperson, we will update it only in the salesperson table, and automatically will be updated in this table for the foreign. So that will save us a lot of hassle. Because in some cases, you might have to make changes. Just if we have a different system, you will make changes here in the salesperson, and then you will have to remember what table this table is linked to, and then you go to that table. So it is messy. But in this relational database, the good thing about it is if you want to make modification or update, you do it only in one table, and it updates it into all other tables automatically. So that's the good thing about using relational database. And that's why we care about where we put the foreign. Okay? So now we understand and we know that the foreign key will be in the mini side. And the justification can be in this way. Now what if we have a many-to-many? Is this many-to-many or many-to-one? What do you think? It is many-to-many relationship. Why? Because we need only the cardinalities when we decide about the naming. So when we have a many-to-many relationship, where should we put the foreign key? So I want you to pause and think. Okay, so just to give the answer, when we have a many-to-many relationship, many database management systems will not are not compatible with many-to-many, so they don't allow many-to-many. So that's one thing to understand. And to avoid this problem of having many-to-many, we need to create an associated entity. So we need to have to create an associated entity for a table ourselves. And that associated entity will contain a composite primary key. So when we say composite from its name, that means it's composed of two or more. So in this case, the composite primary key will be this part of it will be the primary key from this table, and the other part of it will be the primary key from this table. Yeah, this is associated. So now we need to understand that many relational databases, database management systems, they don't allow many-to-many relationships. And they don't support that. So that's why we need to create that associative entity. And this is how it will look like. So we have quantity. And then if I want, I will need to create the salesperson number into this entity. And the product number, I will put it here. And both of those two attributes will be my composite primary key. So they will work as a primary key, part of a primary key, as well as a foreign key. So is it clear now what we mean by that? So if you still want me to talk more about it, what do you think? Is it clear or some more? So, okay. So when we have a many-to-many relationship between two entities, then that's not supported by any database, relational database management system. So what are those database management relationships? Database management systems, DBMS. What are those examples? Is Microsoft Office, Microsoft Access, SQL Server, MySQL, Oracle, and so on. So those, they don't allow to have many-to-many relationships or tables with many-to-many relationships. To avoid this problem, so that way we don't have that problem, we need to create a new table and call it associated entity or associated table. And this associated table will consist of the primary key from this table and the primary key from this table. We will put them together. I hope that I can write. I don't know if it will allow me to write. So I'll put here product ID or number, and then I'll put dots because it works as a prime part of the primary as well as a foreign key, because we are borrowing it from a different table, so it works as a foreign key as well. Is that right? Because it's a primary key somewhere else. So we'll have product number and sales number. So those will be our composite. Is it clear now? And then the quantity, that's nice, we have a quantity. Then we can even include dates if we want. That would be nice. So this is what we mean by associated. It is an entity. We created it when we have many-to-many relationship, and it consists of composite primary key. The composite primary key consists of two parts: the primary key from the one of the tables and the primary key from the other table, and they work as a primary key as well as a foreign key. Okay, is it clearer now? Okay, great. So this is how we converted. When we converted or we created that associative entity, we called it sales. You can just give it any name. It doesn't have. It's not like the Bible. You have to name it certain thing, and you can't. So it is. We called it sales, and as you can see here, the salesperson number came from the salesperson table, and product number came from the product table, and we added the quantity. So now we have other types of relationships. Remember unary relationships, which is one relationship. Remember one of the examples was, can you give me another example other than the salesperson? So if we have products, the products are pieces of or parts of another product. So you're right. So that's another example. What about the relationship between, let's say, father and son? Can we say every person is a father of zero or many sons or daughters and so on? So we are talking about one person. Here we are talking about a salesperson. So we are saying that who can tell me the relationship between those two, assuming or among this one entity, what is the relationship in terms of backup?
Salesperson is back at one.
So what would we say this relationship? Is it one to many to many, or zero to many? So it is one to one relationship. So that's perfect, and that's how we read it. Every salesperson is backed up by one and only one salesperson, and every salesperson is backed up by, and so on. So in this case, how can we convert this entity into a table? So if we have a unary entity, how do we convert it into a table? In this case, we will have only one table. So that means we would have all the elements that we have here, all the attributes that we have that belong to the salesperson, and we will add one more attribute. And that attribute we can call it backup. Backup. This backup number can be salesperson number. Very simple. So is it clear now how we convert unary relationship? Now when we have, what about this relationship? Who can tell me? But it's already said that. So it is one to many relationship in terms of managing. So every salesperson manages zero or many salespersons, because that person, if that salesperson is not manager, then they will manage zero salesperson. And we can read it also the other way. In this case, how do we convert this entity into a table? We will do the same like what we did earlier. So we will create a table with all the elements or the attributes that we have here, and we will add a manager ID or manager number for a manager. And this ID can be this ID. So this here just tells you the rule of thumb, how many tables and so on. And now what if we have a many-to-many? That's what we mentioned about the product. So we said when we have many-to-many relationship for a unary entity, then we will have to have two tables because we have an associated. Okay? So in this case, we will have to create two tables with one associative entity. What did we say about the associative entity? We have to have two parts or composite primaries. So now I will stop here, and tomorrow we will talk, on Thursday we'll talk about normalization. But before, in terms of this chapter, but I want you to work on what you just worked earlier on. So now can you tell me, I want you to work in pairs and look, each one of you look at the relationships that you were assigned to and decide and tell me where you are going to put the foreign keys. So the same entities or the same relationships that you were assigned, and tell me where you will put the foreign key in which table or in which table. For some it might be already there, for some it might not. But if it is there, tell me that it is there. If it is not, then tell me where you are going to put it based on what we just talked about. So let's work with the same groups. ID, like for example, GOO. So number would be the same. So that's what I mentioned. Some of them they are a little yes, they are yes. So that's good. If you know the reason why, you just apply numbers.
Like your professors.
Yes.
Right.
Oh, wait, yeah, I would say like one minute.
Definitely essentially.
Yeah, I don't know. You might. I should work there and you're.
All right, so it should be everyone have already decided. So let's look. So let's look at the first team. I'm a right hand side because when I write from right to left in my native language, so that's why I start from right. So don't be offended if I didn't start from left to right. So let's start.
So since ours was a one-to-one relationship, we decided that you would put the
Can you remind us first what the two entities that you are working on?
professor and student.
Okay, professor and student.
No. And
What is
so
the relationship first between those two?
one-to-one.
So who can tell us?
Oh, one to.
Yeah.
Yeah,
So it's
sorry.
one thing, okay?
And then, so we'll put the foreign key in the student. Is that right?
So is that what you decided?
That's what we decided, but.
What was the reason? Is there a rule of thumb that kind of help you decide that? So that's perfect. You're right. So you will put, what are you gonna put here? That's right. Because that's the concept in that. Perfect. So this is perfect. You read it correctly. You say it is one to many, and you decided that you're gonna put a point in this. So let's look at that.
Ours was the same, so we were student and department, which is a one-to-many relationship. So you take the primary key from the department, which is the one side, which is the department code, and put it in the student side as the foreign key.
Perfect. Look. Third.
Ours is between student and class, And ours is a 0 to many. And so you take the,
0 to many? Is that right, everyone? Who wants to correct them? Please jump.
Many.
So it is many to many. If you look at the maximum. When we read the relationships, we look at the cardinality, means the maximum. So in this case, it is many to many. So I will let you rethink about it. Now you know, discuss it, and then we'll come back to you. So now you know it is many to many. So decide what you are going to do with that. So let's move to the second, to the next.
We have class and room, and so one-to-many relationship.
Class room, okay? It is,
One-to-many
okay?
relationship, and you would want to put, well, it already has room number under the class, and like for the room can hold more than one classroom, so you want to put the room number under the class.
Okay. So based on the rule of thumbs, you put the foreign key in the many sides. Yes. So perfect. That's correct. All right. Let's look at the next theme.
Or the class course. And so it's a one-to-many relationship in the course class. And they already have the primary course ID to one class.
Perfect. Got it.
We have room and building, but the building is
So what is the relationship? Huh? It is one to many? Yeah. So we look at the maximum. So the maximum will be many, and then the maximum there will be one. So one to many, perfect. And there, what did you decide to put the foreign key? Perfect. So what's the rationale or the rule of thumb? So the many side. So yes. So when we have one to many, we put the foreign key in the many side. So good. That's correct. Yeah, let's look at the last theme.
department of course, which is the one to many. So we put department code in the course.
So you will put the foreign key in the course. Perfect. So let's go back to the theme that has the main theme, which is it the easiest one? Is it the easiest one that they got? The many to many? It's not easy, isn't it? So you have to do some work. So what did you decide to do? Where are we going to put the foreign key?
I don't know, what two tables do they have?
They have student and class.
so is that when we make
This is
a new
associated.
table and make the associated?
You put under the student ID and the class ID, both primary keys and associated keys.
Yeah, perfect. So you got it. So that's what you do. So the time helped to think about it. And thank you for your help, because that's correct. You will need to have an associated entity that will consist of the primary key from the student table and the primary key from the class table. And then you can add whatever information or other attributes you want.